This is a video on trigonometric values, identities, and graphs. So to start with, to find the trigonometric values, you need to use the unit circle and 30, 60, 90, and 45, 45, 90 triangles. So we know that sine is vertical and cosine is horizontal, and that the radius of the unit circle is always going to be 1, which means that the hypotenuse of these triangles has to be 1. Now, in these triangles, if you need to find sine of pi over 6, which is sine 30, you're going to use this triangle. You're going to set 1 equal to the hypotenuse. You get that a is equal to 1/2. Then you plug in these values for the other, you plug in 1/2 for a for the other values. So because sine is vertical, it's just going to be a is 1/2. So sine pi over 6 is 1/2. Cosine pi over 6 is 1/2 times root 3, which is root 3 over 2. And for tangent, cosecant, secant, and cotangent, you use these and your prerequisites with, or your not prerequisites, but what you already know with the sine and cosine, because you already have these values, to solve for all of these. And you can do the same for any of these, pi over 6, pi over 4, pi over 3, any of those. You just use these triangles, the corresponding triangles, and solve for the hypotenuse for a, using 1 as a hypotenuse, and then use these if you need to. And just as a side note, radians, this would be the conversion. Pi is the equivalent of about 180 radians. And yeah, so here we're going to prove the Pythagorean identities. We already have these, so we need to, just using the original Pythagorean identity, which is a squared plus b squared equals c squared, we know that sine is vertical and cosine is horizontal, and that c, the hypotenuse, is 1 because the radius of the unit circle is 1, which means that a squared, sine squared, b squared is going to be cosine squared, and c squared is 1 squared, which is just 1. So sine squared plus cosine squared equals 1. To derive the other ones, you have to divide by sine squared. So dividing this whole thing by sine squared divided by sine squared is 1, cosine squared divided by sine squared. We can look here, cosine divided by sine is cotangent, so cosine squared divided by sine squared is going to be equal to tangent squared. 1 over sine squared, 1 over sine is cosecant, so 1 over sine squared is going to be cosecant squared. So, and then we can, so this is the second one. Another one, the last one we have to derive is you can derive it by dividing the whole thing by cosine squared. So sine squared divided by cosine squared, sine divided by cosine is tangent, so sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is going to be 1, and 1 divided by cosine squared, 1 over cosine is secant, so 1 over cosine squared is secant squared. That's the last one. Here's a way to remember them. This one you just derive using Pythagorean identity. You can derive all of them, but it's easy to just know them off the top of your head. What you can do, look, cotton cascade, tan secretary. If you remember where the ones go, you're all set. And this one you can remember, the S in the middle, sine. This one's the reciprocal, the letters. It starts with an S, ends with a C, starts with a C, ends with an S. So those are little like pairs. And these ones are the only ones with T's in them, so they're also like pairs. And then cotangent is cosine over sine. Cotangent starts with a C, and cosine divided by sine starts with a C. So that's a way to remember that these are pairs, and because cotangent is 1 over tangent, you know that these are going to be opposites. So tangent theta is going to be equal to sine theta over cosine theta. Here are some problems to solve. In these kinds of problems, you have to only work with one side. So what I did is I chose the most difficult side and tried to simplify it down to 1. So I factored here. I got sine squared x minus cosine squared x times sine squared x plus cosine squared x. And then I realized that this factor is the same as the denominator, which means it cross out. And then I just got sine squared plus cosine squared is equal to 1. And because up here we proved this, we can just substitute in 1 for this. So 1 equals 1. We proved it. Here are the graphs of sine, cosine, cosecant, secant, tangent, and cotangent. So sine, by looking at the unit circle that we made here, sine, it goes 0, max, 0, min, oh, what am I doing? Yeah, 0, max, 0, min, 0 again. You can see that same pattern here. Cosine goes max, 0, min, 0, max. You can see that same pattern here. And because cosecant is equal to 1 over sine, whenever the denominator, sine, is 0, it's going to have a vertical asymptote. So you can see the vertical asymptotes at the zeros, and 1 divided by 1 is 1. 1 divided by negative 1 is going to be negative 1. And whenever it's positive, it curls up. Whenever it's negative, it curls down. The same thing for cosine. Secant is 1 over cosine, so whenever the denominator is 0, it's going to have a vertical asymptote. And at these maximum values, you just divide 1 by the maximum value here. Whenever it's positive, it curls up. Whenever it's negative, it curls down. Tangent is sine over cosine, as you can see here. So whenever cosine, the denominator is 0, there's going to be vertical asymptote. You can see that the vertical asymptotes are reflected in these the higher graphs. And whenever the numerator, sine, is 0, it's going to be 0. The tangent is going to be 0. So, and then it also follows this little pattern, like it almost looks like a cubic function. And just remember that tangent is increasing, cotangent is decreasing. So cotangent is cosine over sine, as you can see here. So whenever cosine is 0, it's going to have a 0, and whenever sine, the denominator is 0, it's going to have a vertical asymptote. So you can see that here. Whenever the sine is 0, there's vertical asymptotes. And it's going to have the same pattern that tangent did, kind of like a cubic function, except it's going to be decreasing instead of increasing. Here is how, if you get these kinds of questions that are asked to graph, how you do it. So there's basically 4 things that can be changed in any from the original graphs, these 6, which is amplitude. There's which is like a vertical stretch. You can change the period, which is a horizontal stretch, and you can do a vertical and a horizontal shift. So this one's an amplitude. Just means that anything that's the max or the min, anything you multiply by 2 pretty much. It's just stretched up to. Not up to, it's stretched by 2. So you multiply everything by 2. And the period is typically 2 pi for sine and cosine, and all of these, it's pi. The period means just how long it takes for it to complete like one round of its pattern. And so 2 pi is its typical period for sine, which means that you divide by 2 here, the thing in front of the variable, and you get pi. So the period is pi here. You still split it up into 4 pieces, and the mins and the maxes are still at the same location compared to the period, if you want to put it that way. The max is at 1/4 of the period, and so forth and so on. And so yeah, it has the same shape. It keeps the same shape for the most part. And then here we have a horizontal shift and a change in period. So you have to take the 2 out to get this horizontal shift. Plus pi over 4 means pi over 4 to the left, and this 2 here means that the period is going to be changed again. So 2 pi, cosine is 2 pi, this period. So 2 pi divided by 2 is equal to pi. You split up into 4 pieces. Again, you'd graph it like normal, except you change everything. You move everything pi over 4 to the left. And tangent here, tangent theta plus 1, it's just a vertical shift up 1. So everything is just going to be added 1. You just add 1 to every y value. So yeah, and it's going to retain its shape for the most part. So thank you for watching.